Laboratories step at a computer science course. I'm here with lots of people who spoke in and all sorts of people here on the internet. Yeah, basically, this is how I think we're going to try to work things in the future, where I will be kind of going back and forth between our beautiful faces and the slides. If you're watching live on the Hangout, you can probably actually just click on any of the images to see what images you want. I sent you guys all the slides as well. If you want to just run those on your computer, feel free to. But yeah, so today we are going to be talking about how, what is computer science. So yeah, this is CS5 is the course material from Harvey Mudd College. Their like unofficial mascot, little right here. It's like these like buildings have this like actual like tiling where they have these like cinder blocks with these little like concrete squares out of them. They call it like billboards or whatever. So if you're ever in Southern California, an hour east of Los Angeles, and feel like a very boring field trip, you can swing by Harvey Mudd College and check it out for yourself. Yeah, so today we're going to be talking a little bit about the course material and then going into Python. We've kind of covered a lot about how the course works for us. Those slides got chopped out because they're pretty specific to like, hey, we're going to go on the Harvey Mudd campus to go to the lab sections. Here's one course classes, which you guys already know. But then the big thing we're going to be covering too is what is computer science? So, what is computer science? Computers? Whitney?
Well, science.
What's that? Alright. So it's not equal, it's not programming. It's not just programming. And you'll see this will run into very commonly, but this exclamation point equals means not equal to. What it is, like computer science analogy as like language is to ideas, like equations are to mathematics. Basically, it's a part of computer science. It's really like a tool for doing computer science, but it's not actually what computer science is really about.
Make those full screen too.
If you make it full screen, Google Hangouts can't figure it out.
Oh, really?
So,
Gotcha.
yes. So you guys get to all see the border around PowerPoint. In case you've never seen what PowerPoint looks like, studying an old chunk. So computer science is the science. It's one of their definitions is the study of complexity. Like how do we do things? How well can we do them? And can we do them at all? So that's what we're going to be kind of looking into as we kind of go through this course. Hey, Jesse, talking about what exactly computer science is. So studying complexity. That makes sense to you guys?
Yep.
Mostly we're going to talk about here in terms of information. We'll be talking a lot about how we transform data from one form to another, how we analyze it, how we basically take in information from some part of the world or some file somewhere and turn it into something useful. Something that we want, went from an input to an output. We're going to get a couple of examples about what and we'll actually be doing them in this course. But yeah. So, how can it be done? It's kind of the first question that we talk about. Like, can you solve a problem, and can you create a process to solve like a generalized form of that problem? So an example here is what's the longest common subsequence between two strings? This becomes super useful, like if we're in biology, we want to compare like how similar a human to a chimpanzee is. We can take our DNA-based sequences and compare. Like how common, is there a little chunk inside this big long sequence of characters that matches up? And how big are those chunks in usual? And so, Are we chimpanzees? Are we more closely related to birds? Whatever. Kind of the second question to look at is how well can it be done? How quickly can we find a solution, and how is the solution the best? Is the most efficient? Does it use the least memory? There's an example with this program called the Universe Sandbox. It's the universe. I'm trying to be all physically accurate. How much work do we need to simulate a galaxy with n number of stars? What happens when that number goes from 100 to 1,000 to 10 billion? Finally, can it be done at all? We'll be looking at this. We may actually be not looking at it. This is kind of the last bit of the course. We may not really go into it. It's much more on the theoretical end. But kind of computer science, really one of the big problems or concepts in computer science is this idea of computability and whether or not you can even create a program that can solve a problem.
Is that a problem or the specific one that we theoretically are thinking about that we want to solve?
Say again?
Well, you were kind of talking generally and talking about things that we can study complexity of and solve a problem. So you have that sort of generic problem idea.
Yeah.
So when you said the next sentence in terms of whether or not it's possible to solve a problem, were you speaking Czech? That idea that we've come up with a problem that we're trying to deal with specifically, and we're trying to decide if we can apply computer science to that specific thing.
Yeah, I mean, it's kind of a question given a specific problem, is that solvable?
Right. Okay.
Fortunately, most problems, most of the stuff I think we'll want to do are solvable, but certainly on the more theoretical side, the classic example is it is impossible to create a program that will figure out whether or not another program will run forever. You can prove that is not. You can't make it write a program that will always solve that problem correctly. We can go into that at the very end of the course. We're going to be taking this course, and we're chopping about 4 weeks out of it. And those sections are mostly in kind of the really low-level stuff around assembly language and how the chip actually works on an electrical level. But so some of the stuff is more kind of theoretical, like the modeling of the computer as a system. That stuff, it gets interesting if you're into the theory, but it's super not practical for actually making stuff happen for a life. So, but there are interesting classes of problems. I mean, on the more practical side, like this one, can we build a 3D model from 1 to the image? If we have a single photograph of a building, can we create a program that's going to be able to look at that and say, okay, I'm going to build you a 3D model of this? So yeah, it kind of comes back to the question of what's computer science, and it being the study of complexity. We kind of wind up having 6 big questions in computer science. You solve a problem. Can you make a process to solve it? How quickly can you find the answers? Do you have the best way to find the answers? And then is every problem solvable? And is there a way to tell? Only one of them is programming. Do you guys have an idea of which of those questions that programming actually solves?
Is that the process to solve such problems?
Exactly. So all of these are computer science. Programming is the specific little tiny chunk of computer science that is, yeah, how do you actually make something do something? So, kind of answer a little bit about what is computer science. Does that make sense to everybody? Do you guys have any questions around computer science? And is there anything that you guys?
No, it's okay. And I'm following. I I don't have any questions. Fine.
Sure. So, one of the things that we're going to be looking at today specifically is rock, paper, scissors, and the variant thereof. Rock, paper, scissors is kind of this, triangle of rock beats paper beats scissors. Doesn't matter. Rock beats scissors beats paper beats rock. But you can actually extend that to however many, and this variation off of internet. Yeah, we'll be looking at that. So, the syllabus that we kind of already covered last week. We have lectures, we have labs. You guys need to have further questions. Appointment with me. Homework, which we haven't really talked about, you'll be getting the link to the first homework today. Go ahead and have that due similarly on Sunday night, so give me a little bit of time to look over your guys' stuff on Monday. About it. Again, labs. I'll go find homework. So about the labs. So we kind of covered this last session. If any of you guys aren't here, watching at home, I didn't get not gonna bother. Homework. There are about 5 problems a week. We're gonna have them do sentences, so ignore that. And this extension thing, haven't played it. Realistically, the homework is good to do it, but it is a important part of the school. It's probably what you learn. I would definitely recommend doing it. Collaborate is a big theme on this. One of the things that I feel make it fun, but also help it be easier to learn is if you do kind of pair programming, if you work online with Cloud9 or just in person if you're that. I also encourage you guys to kind of laboratory. A great opportunity to build that. I'm gonna turn off the music. Just that right here. Let's talk over it. So, the two that CS5 deals with kind of working collaboratively is adaptive pairs, which I probably recommend the most, where you're both working on the same computer, they can do one set of code at the same time. And one person's typing things, and the other person's kind of talking back and forth with them, as opposed to you're working on a problem together separately. If you're remote or partner, we're kind of, I guess, doing kind of a hybrid of this computers thing. Using Cloud9, you'll be able to work on the same set of code at the same time, like Google Docs, which is awesome. Yeah, so I would probably set up a video chat window and some another window, and then work with a partner that way. Yeah, submission, you'll probably the easiest way is to do stuff on Cloud9 and share me into the project. That way I can kind of just come in, take the code, run the tests that I need to run on it. Then, yes, if you share me, it'll probably be that also can come in and help you out with your code. Hours. The honor code is a Harvey Mudd thing that I take very seriously about not cheating. You're encouraged to discuss things. Probably don't go look up the answers to homework on the internet. I can't do anything to stop you, but like you're just like cheating yourself if you know don't do homework. You're all grown ups, you're all adults. Those are kind of Harvey Mudd when they do this course. Notice 65% of the grade is assignments. It reflects how important homework is. Where are you going to get the learning? You talking to how you do that? Yeah, so talking about it's kind of a cute way that they're starting off in regard to how do you programming Python. So this is the way that they're calculating grades. And your percentage right up here. We're going to have this like variable called percent perk. And we're going to set it using equals and 1. And you gotta have the print commands that we had last week. What is we're going to print if we do print stuff? Perk. Awesome. You guys thinking that it's going to print A minus. What's going to happen is we're going to go through here. And if perk is greater than 0.95, colon, which says do this, print A. If it's not this, it goes to the next statement. This elif stands for else if. So if perk is greater than 90, print A minus. If that wasn't true, we drop down to elif perk is greater than 70, pass. And then if none of those are true, we finally go down to the else statement, which prints R. So something that we'll kind of go through in some of these slides. So each chunk of code here, kind of a self-contained statement, a block of code. So this kind of if, then do this. Else if, do this.
So how does it know if it does the first one? How does it know that it's stopped? Because all of if 0.97,
Yeah.
all of them qualify as being greater than whatever the number is. So you could potentially print all of them.
We'll run into that in just a second.
Okay.
No. That's a great question. Important thing to us is that, so this classic thing in computer science, the first thing we're going to is the if-then construction, the if-then-else construction. It's known as a control structure. And it's this idea that we're going to take two values, compare them, and if the comparison is true, we're going to do something. So if-then. And if it's not true, we're going to do something else. If, then, if. That's not true. Else. So elif is the way Python says. In other languages, it's the else if. Python does it elif. And finally, this else statement in it. So, one thing about control structures kind of comes to a little bit to Kurt's point. Order is obviously. So which does each of these programs, what is the program on the left? Jesse, Rebecca? You guys have any thoughts on these programs?
Nope.
Awesome. So let's go ahead and work through this then. So first line, Mind if I put you on the spot, Jesse?
Yeah.
So what's going on in this first line here?
On the right or on both of them?
On the left here.
So on the left, it's perk equals 80, or 0.80.
Awesome. So then what does the program do next on this line?
If perk is greater than 0.95, print A.
Sure. Does it do that?
I think so.
So why would it do that? So we set perk to 80 up here, and we're asking perk is greater than 95. So is perk greater than 95?
No. It's equal to 80.
Right. So perk is not greater than 95, so
So it can't print A.
can't print it. So then
Yeah.
L, we jump down to here, right?
Mm-hmm.
So is perk greater than 90?
No. Sure
Yeah.
isn't.
So now then we jump down to here. Perk greater than 70.
Finally. Yes, it is.
Awesome. So what do we do? What happens next?
So since perk is greater than 70, then it's going to print pass.
Awesome. Sweet.
Does that mean for everything else, though, would it print arg?
So if perk is less, so first we test if perk is greater than 95. So anything that's greater than 95 prints A. Then if that's not true, anything that's greater than 90 prints A minus. Then if neither of these two are true, and we're greater than 0.7, print pass. And then anything that's 70 or below, we print arg.
Yeah, okay.
Which kind of brings us to the right-hand side. You guys think the right-hand side is going to print out? Print arg.
It's going to print arg for everything.
Awesome. So
That kind of answered this question, so it's the order that it's in. So if that was lower,
not cool. Getting to that probably in the next slide or two, I think. So one thing that we can look at. Yeah. Awesome. Yeah, so I'm just going down these questions. What does each of these programs print out? I covered that. Okay, so what value of perk gives an A minus on the right-hand side? Kind of a trick question. I've already figured out that everything prints out.
Yeah, everything prints arg, so
Although that's not entirely accurate.
what if that?
everything above 0 prints arg, right?
That's
So
absolutely.
if it's a negative number, then it would do something different.
Yeah, so how can you, so if it were a negative number, what would you get on this right side?
Probably an error. I don't know, because it would compare it to the 80%. But technically, the 0.8 is an arg as well, so
So,
it's greater.
so actually, so this statement up here is not a compare, and this will trip you up for a while, but I still get it wrong sometimes. This is an important point. if you want to compare two numbers to see if they're equal, this is nearly universal across programming languages. Hit double equals. Equals alone, what's known as the assignment operator.
Well, what is double equals?
Double equals compares whether or not two values are equal.
That's the same in processing, right?
Yeah. So if we want to, so what the single equals does is it takes the value on the right-hand side here and puts it into the variable on the left-hand side. So what we're actually doing when we're trying to make comparisons, so if we wanted to do a negative number, like let's say if perk is equal to negative 0.80. So what happens now?
Anything, or you said is equal to negative 0.8?
Yeah, so let's put perk equal to negative 8. Walk us through how the code is. So yeah, perk equals negative 8. What are we doing?
So if percent is above 0, you're going to get arg. So for any of the percents less than 0 or in the negative, you're probably going to get a pass as long as it's like a 80 or a negative 0.8.
So this is greater than.
Larger.
That's not totally true. So if perk is greater than 0, not because it's less than 0, we print arg. Else, if perk is greater than 0.70, it still isn't print pass. Does that make sense?
Yeah.
Oh.
So we keep going. So keep walking me through it, Jesse.
Right, so it'll give you the A even if you had a negative grade.
Yeah.
Yeah. So let me do this other comparison. These two comparisons, since this one already checked anything greater than 0, since we have this else if statement, these will never run. But if we're less than 0 or equal to 0, we jump to if, else if, else if, else is this, describing this catch-all. So if none of these are true, so it's an else statement.
Okay.
That making sense to all you guys? Adam? Is that making sense? Ready? Rebecca?
Well, so that answers the question in the bottom, like which value of perk gives you a B minus on the right, or how can you get a better grade on the right than the left? Because on the left, the else statement is arg. So if nothing else is computing, then it's just going to go to arg. Versus on the other side, if nothing else is computing, then you just get an A.
Exactly.
Okay.
It's making sense to you, Rebecca?
So the leading line, it's not a chain of command, it's a command and then exceptions? Does that make sense?
Kind of. I mean, exceptions is kind of a
So you
loaded.
have a rule and then you have the exception.
Yeah, so
Okay, or parameters.
Yeah, so I say that again?
Okay, so you make a general rule and then what follows that is parameters?
Yeah. Basically, you're saying if something's true, then do something.
Yeah.
Else, otherwise, if something, this is basically, and you'll see else if in other languages.
Okay.
Otherwise, then do another comparison if you want. Then otherwise, do another comparison if you want. And then finally,
Okay.
else, otherwise, if nothing in that chain was true, do this in the very last else block. And so,
Yeah, that makes sense.
If you wanted to fix this, you could do a less than.
yeah.
So if the perk was less than 0.7, then print R.
Mhm.
And that would solve it for any value under this 0.7.
Yeah. this making sense to you, Ilaria?
I think so.
Awesome. Please pipe up with questions if you have them. I kind of tend to talk a lot, and you guys are very, very small on the screen, so I can't really see you guys. So, yeah. So now we're going to talk a little bit about Kurt's original kind of question about how these things fall through. So these are all known as exclusive choices. So we have if Kirk is greater than 95. So these are all mutually exclusive blocks of code. When using the if, elif, else structure, at most only one of these blocks will ever run. Yeah, if all of them fail, then the else runs. And grab a glass of water real quick. But what happens if we don't have the else ifs? But it's going to happen here on for the mutually exclusive blocks, say equals what happens in this left block with the mutually, or actually let's do 20. What do we get in this left-hand block? A minus. Yep. We go check this. It's not greater than 95. Okay, else, well, it is greater than 90. And then we print this, and then we're done. What happens? In this block. Just a little about it so they can hear. Let's walk through it. So Perk is 92. Yeah. So we don't print the first one because Perk is greater than 95. We ignore that. But we're completely out of this control structure. No else, no elif. So we're just like, okay, time to run new code. So let's compare it. Perk greater than 90. Sure it is. So print A minus. Then no else, no elif. Just a regular if. We're in a totally new control structure. So, oh, is Perk greater than 70? Totally. So we print past. Does that make sense?
Now, it will do both?
Yep. Okay. It'll print out an A minus and then pass.
I have a question.
Yeah.
So, point 92 or point a number, what is that like a unit? So why is not 0 point? I mean, I'm confused about the way the numbers are written in this example.
Sure. Yeah, in Python and in most other languages, I think if the first number is a 0, you can ignore that. So this is actually 0.092 and 0.0.
Okay. So it's the same than we had before. Just we're ignoring that 0. But okay.
Yep. Good question. So now the one last thing for making decision making. So we're going to start talking about the rock, paper, scissors that we were talking about earlier. Take a look at this. Let's walk through each of the lines. This first line here. These two are known as variables, comp and user, assigning rock and paper into the variable. Variables are like boxes for blinking. So we're asking comp is paper, user is paper. Not quite. So this and here is a kind of a Boolean operator. It basically lets you have multiple statements. We're asking for the double equals compares what's on the left on the right, and returns true if they're equal and returns false if they're not. Is comp equal to paper? Is the value that we stored in comp equal to paper? In this case, it's not. It's comp equals rock. And user equals paper. User does equal paper. But since comp equaling paper and user equaling paper, so not both true, we jump down to that else. Now we do comparisons from rock, which it is. That jumps us into this next block of code. The second nested comparison. Users equal to scissors, so print win. Otherwise, print movement. So both of these only will happen, both of these statements only happen if comp is equal to rock. So scissors would happen like this. Comp isn't equal to scissors, so we don't do this. Give them all comp. Still not, comp is not equal to rock because comp is equal to scissors. We don't do this code either, and nothing gets printed.
Okay. So nothing gets print?
Do I say again?
Nothing gets print?
Nothing prints, yeah, if comp is equal to scissors.
Okay.
Comp is equal to scissors, nothing prints because nothing...
Oh, okay. No, but with comp equal rocks,
It's already stated that.
Yes. So if comp equals rock,
So the like full name is not full name laid out.
so yeah, so I have comp is equal to rock, we jump down to this statement, this block.
So shouldn't it print you win arg?
Yep.
Okay.
Yeah.
Sorry, is that the audio is very disturbed, so I get like one word here and there.
Ooh, I'm sorry. I need to get a better computer to run this. I'm sorry.
No, it's fine. Just
Let me actually see if I can switch the audio. I wonder if I'm... All right, sorry about that. This. So is this making sense to everybody?
yeah.
Why wouldn't rock work if user was rock in the second one? Why wouldn't it? I mean, obviously that wouldn't work in real life, but how?
Yeah, that would happen.
That would?
Yep.
Why? All right. So that is what happened.
Yeah.
But wouldn't that be fine if you go to rock to rock?
Yeah, totally. This piece of code is not. Yeah, and we have this kind of question up here. Does this program print the correct rock, paper, scissors result this time, and does it always?
Oh, I didn't see that. Gotcha.
Yeah, no worries. So, yeah, almost you guys will be writing rock, paper, scissors code, I think.
Yeah.
Sweet. But, yeah. That actually brings us to the quiz. I think the best way for you guys to do this remotely, I'm actually going to hand out pieces of paper to you guys. Partner up. Okay, through at each other. Maybe Kurt and Computability. That's a two-partner quiz. So if you guys want to, I guess I should talk. Maybe if you guys wanted to start your own like separate video chats, abroad, but or maybe like in the chat window, you guys could answer the questions since there's only 3 of you. Kind of with the favorite, least favorites. Maybe talk amongst yourselves about what you guys have in common. Yeah, and then we'll let these guys kind of work on this. Maybe you guys via the Hangout can do the Python questions. That work for you guys?
Oh, yeah.
Should we do the quiz?
Yeah.
Okay.
If you guys want to, if you online guys want to maybe either do it in the group chat.
Sure.
Valeria, are you on group chat? I see where Jesse and I are.
2 spots.
Would you join us?
Are we sharing a piece of paper, or are we supposed? Are we?
You can share. Probably share. Makes the most sense.
Yeah, 2 names last year. So. I think the favorite. Yeah.
Oh.
And is that correct?
Yes.
And then favorite is, so is that our favorite, or our favorite color? Okay. Who's non-primary? Ecology? Ecology?
The 3 tests.
Woody, you're gonna, what is this?
Oh, thermocology. So I think that's like people that went originated there.
Yeah. So the Claremont colleges is. None of you guys go to the Claremont colleges. You probably don't have anything in common with the Claremont colleges.
And are these favorite, least favorite, this is fun? Like,
Yes.
Oh, gotcha.
Nope.
Oh, so I could be like, my favorite food is mac and cheese.
Totally.
Gotcha.
okay.
Um,
Nice, Rebecca. Do you canoe, Rebecca?
opening the wrong window. Oh dear.
I have a question.
What's up?
What's it? RPS.
That's rock, paper,
Rock,
scissors.
paper, scissors.
Yeah.
What?
Right.
White paper?
Rock, paper, scissors.
Else it.
And well, else if. Okay.
Okay, what's next?
Yes, let's.
Right. So
Question 0.
this is.
So what are the 3 blocks, the 3 tests and the 4 code blocks here?
So if one of these was caught, then
The slides on my phone. Let's see.
first was satisfied.
But if it can't act on that.
No, because theoretically it could print both.
And if it can't act on that, then
If the user was paper,
and it,
I win.
we
And
didn't exactly talk about this, but
but if
this
there's
is
anything, any
this
other
is a
combination,
condition.
like both these were scissors, then I think we print tie. Or if one was scissors and even.
Right. A block.
Yes.
It's striking me that on the larger
Pretty much
systems,
nothing, right?
a block is
Sure.
any piece of instruction.
So my logic with this is I think.
I'm good with that, yeah.
Yeah, good.
I'm fine with that.
Well, it gives us the number.
Rock and roll.
That right?
Okay.
If the user, both your statements die, and it's not anything else other than this thing, so it's gonna right? Friends, I win.
It's just this. So it's kind of like, we would just look at this and say, yep, this is what we're going for.
Right. I think so. That's print.
Yeah.
Bad programming. Bad programming. Well, it's taking these instructions, economics, rock, going to print this. Well, the question is, we want to change the inputs. Change the input, and we can make this an accurate event. That doesn't mean change the input. Correct. So,
But I think if we change this to scissors,
and
this,
this to paper,
yeah, or this to
we can change that. Change this. So here's this.
What if we change this to paper?
Oh, wait.
Paper, the only output. It would print.
This one doesn't satisfy this. Oh.
No, I'm under the.
Oh,
Alright.
Oh, there's a little graph. That's
Yeah,
nice.
Scissors and paper. So
And it won't print.
Correct.
Then,
So let's work through problem 2 real quick. Let's kind of bring everybody back together. We'll kind of go through 1 and 2. And now, everybody's there. How are you guys doing?
we're on, yeah, we're doing it around.
Just go.
yeah.
All right.
Like.
Let's go ahead and pause real quick. Kind of come back together and go through questions 1, 0 through 2. Back towards everybody. Awesome. So, question 0, we're just kind of looking at blocks of code and tests. I don't think I used the word test before. These are all also called conditionals. We're testing the condition of a variable or of a statement. Yeah, so we're doing tests. Is comp equal to rock? Is user equal to paper? Or is user equal to scissors? Those are the 3 tests that we have. And the 4 blocks of code we have. So this is 1 block. This is the 2nd block. Within this 1st block, we have this 3rd block, and then this 4th block. Does that make sense to everybody? Is that what you guys got? Do you have any questions?
Mhm.
So, yeah. So we have 4 blocks here. We have the thing is a block because we're taking this conditional
Oh, okay.
and running all of this code is controlled by this.
That block. Sub-block.
Well, within this block, there are 2 blocks. You have this block, this sub-block, and this block is kind of part of. It's like,
And is that a block?
yeah. So this is a
The
block.
else is a block.
So you have this if block and this else block.
Oh, okay. And the comp user information out of the block.
Yeah, not kind of block it here. Just somebody who's smarter than me down here.
That part.
Jump down.
Oh.
Yeah,
We're not handing.
that's cool. Awesome. So, yeah, the slides, you can jump ahead to the cheat notes. Yeah. Yeah, so we're back down here. So now let's go through question 2. You want to work us through this, Ilaria?
Question 2.
Yeah.
So yeah. So we have comp and user are both rock.
Yep.
So if comp equal rock, then print I win.
Yep.
And that's correct. And then
Yep.
if user equal paper, print you win, but we don't have paper. Else print tie, but we don't need else because it's gonna execute the first if, right?
So this is kind of a little bit of a tricky question. I think Connor and Adam ran into this as well. I'm not sure if you guys got to. So this if, this if, it's like it doesn't have an else statement attached to it. It's saying if comp is equal to rock, print I win.
Right. Just does that.
It just does that. Exactly.
whether it's correct or not.
Then it jumps down to this second set of conditionals, which is if users equal to paper, else. So these guys are linked, but this else statement is not connected to this first if.
Ah,
That makes sense to all you guys?
okay. So, but when we write this to program, we should have like if they're all attached, they're gonna, I'm confused about that. Like, how do I know that they're not connected?
So we know they're not connected because if always starts a fresh block.
Okay.
If we wanted, that's what the elif that we've been running into all the time. That's like else if. Since we don't have that, this is kind of a code thing, so Python's a little bit different than a lot of language, and white space does matter. White space means spaces, tabs, but enter, like you can have as many blank lines, and the computer just ignores those.
Okay.
So like this, I would definitely recommend separating each block by a couple of new lines. And we already see this, like comp equals rock, user equals rock, then there's a space. And this is just something that we do to add to the readability of the code because, yeah, I mean, code like this where just if, else, like that totally looks like all three of these things, or all three of these blocks are totally related and interconnected, when it's actually only these two blocks that have the If else, it's kind of like parentheses, where if opens, starts the statement, and then else kind of closes it. But it was a terrible analogy, because you can only do an if without an else, and just an else just implied else don't do anything.
So the audio is coming and going. I
had the same problem.
Sure.
So what you're saying is that if the if is connected to the else, then those are connected, but two ifs are not connected.
Yes.
Okay.
So if you hit an if, and you don't another if, or in Python, if you go back into, so Python uses the tab, the indentation here, to like set up its blocks of code. So if we were to be like down here, user equals scissors. The user started at rock, then we changed it to scissors down here.
okay.
This asks this block, so we're into new code now. This if statement is totally done, as we kind of jumped back to this. Yeah, so now with that, what is it going to print?
I win and tie.
Yep, that's absolutely correct. Why is that?
Because it will go through the first if and find rock. And so print I win, and then it will go down not finding paper, it will go to else, which is tie.
Awesome. Sweet. So how would you change these two to make this print out the correct, the correct answer? Right now, this doesn't give anything. What would you comp this program to give a correct answer?
You would change it to rock and paper instead of rock and rock.
Can we change?
So can you walk through what would happen if you changed it to your answer, Jesse?
So if you changed it to rock and paper, so for the first one it would work, and then for the second one it would also work. You would never hit else, or you would never hit tie, I guess.
Right. But, so we would get this, like, I win and you win, which is not the right answer, right?
Yeah.
So, yeah, well, what's another combination that we could try to see whether or not this correctly we get?
Oh. Change the other rock, or the user rock to scissors.
So how would this work? Walk us through.
So if the computer was rock, then that beats scissors. So rock wins, or computer wins. If the user is scissors, then rock still beats scissors, and comp still wins.
Right, but so we do this comparison, and we print out I win, right? But then
Yeah.
comparison is rock is user equal to paper. It's not. So then we jump down to tie, right?
Yeah.
And so this will print out I win and tie, right? So that's also not an accurate thing because so we need to get this to print out only one response.
Oh, okay.
Yeah.
Ah, okay. So,
Would you prefer rock to paper? Because then wouldn't it tie?
Yes, that would print out tie, but so this is got a tie.
so but
Go ahead.
what does it mean? I mean, when we say completely correct, correct outputs, correct means only one output.
Only one output, and it's the proper answer to this game of rock, paper, scissors between the computer and the user. So what would happen if we try scissors for both?
Tie.
Yep. That's awesome.
Oh, okay.
Yeah. That make sense, Jesse?
Yeah, because that's the else.
Awesome. That make sense for you guys? Cool. Kind of moving along. There are a couple other. Are you curious about the other two questions on the quiz? Do you want to go through those? Cool. So we kind of exhausted four. What do you guys think? Are there any other correct answers or any answers that will be in the program?
Forgot about the.
Okay.
Yeah, this is trickily written, so only scissors is the correct answer. The rest of them will either print the wrong answer or print out two answers.
Okay. Yeah.
Yeah, and then so the question: what's the smallest number of blocks of tests you need to complete a full game of rock paper scissors? What's the smallest number of blocks of tests that you need for a full game of rock paper?
Would it be 3 tests?
So, why do you think that? Yeah, let's look at this one together.
Well, so in like the right side example or second example, as long as like comp and the user equal scissors, like you'll at least tie until the game's done.
Sorry, say that again?
So like in the second example, so as long as like you have it set up so that it's comp and user equal scissors, and then you go through the 3 tests, like no matter what, you're just tied. So
Right.
game's done.
Yeah, so I guess, I mean, the question is, given any combination down here between comp and user being rock, paper, and scissors, rock, paper, and scissors,
Okay.
if these can change any possible combination, what's the smallest number of tests we'd have to make to be able to handle every possible case? Correctly. How'd you do it?
Good.
Okay.
Well, I don't know. So that's one. And all of it are variable. That would be 4 blocks. And 1 block, that's 5. But I don't know. So on,
But I think the answer is probably going to be along the lines of the Kurt was saying. So we take away the 3 sections, rock, rock, paper, or scissors, scissors. That's it. Comp is equal to, then we basically have a special case then here's the back. Here's you guys can put a program that you're not going to use. Look at it. We'll actually bring the next year. We'll have lap on Friday. So, awesome. So, yeah, I think you guys all link to the homework. Weird. You guys all do but it has the homework on it and the Harvey Mudd website.
I can't hear well.
Let me try this. Do you guys hear this better?
Yeah.
Yes.
Yeah.
That's probably what it is. I'm just running on a crappy computer.
Oh, that's good.
Yeah, I think the screen sharing that I was trying to do probably was hurting things. So probably next time just leave this down there. You guys can you guys click on the Connors to get the screen slides on your screens?
Mm-hmm.
Yeah.
Awesome. That's probably going to be the easiest way to do it, because we'll be able to put up the screens or the slides on our big screen here, and just run this for you guys then next week. Yeah, sorry for all of you guys who are watching this on the YouTube channel, because the audio is probably going to suck, and I'm sorry about that. Shoot me all the questions, and we can set up a time to Skype and figure some of this stuff out. I'd be happy to kind of basically go over these slides with you one-on-one. We'll have class on Wednesday, and I sent you guys all a link to homework. If you're watching this on YouTube randomly and you didn't get an email with the homework because you're this course sometime later, maybe I sent you the link to this like 2 years from now. If you do a Google search for HMC CS5, like HMC space CS5 for Harvey Mudd College CS5 course, there will be a web page that will have a link to all of the homeworks and all the lecture slides. So feel free to go ahead and do that. I will see you guys in 2 days, and then Friday morning, if you guys want to show up, and we can all work on the homework together.
Okay.
Hey, do you guys have questions?
Cool.
So,
Thank you. Thank you for the mind massage this evening, and we'll see you Wednesday then, I suppose.
That's great.
Yeah.
All right, awesome. Thanks, Chatham.
thank you.